Good afternoon. Welcome to today's lesson on section 8.2. Section 8.2 is titled Graph Simple Rational Functions. Sorry I didn't make a worksheet this time. Kind of running a pretty tight schedule, so also have to just do it like this. First of all, let's define a rational function. So a rational function has the form p over x over q over x, where p of x and q of x are both polynomial functions. So to give you some examples, if we had f of x equals x plus 1 over x squared, that's a rational function because we have x plus 1 is a polynomial, x squared is another polynomial. Or if I have something like that, 2 is still considered a polynomial even though it's one term. That's just like graphing y equals 2. But x minus 3, that's also a polynomial. So as long as you have something over something and they're polynomials, so no like radicals or anything like that, or logs or exponential functions, this will be considered a rational function. So again, it has to be a ratio of 2 polynomial functions. That's the best way to define a rational function. Kind of like a rational number, ratio of 2 integers, so kind of similar. So let's get to some examples right now. Because we're talking about graphing simple rational functions. So we'll go with the simplest we can think of. Let's graph y equals 1 over x. Now whenever you see a brand new function and you're trying to graph it, always helps to make a table just to see how the general shape should be. And this will be, by the way, the parent function for rational functions. So I could plug in 1 and y is 1. Plug in 2, y is half. Heck, if I plug in 3, I get 1/3. Plug in negative 1, I get negative 1. Negative 2, negative half. Negative 3, negative 1/3. And if I were to plug in like fractions, like 1/2, I get 2. Negative half, I get negative 2. So now let's graph coordinate plane. Here I go at coordinate plane. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Let's change up colors. So 1, 1 would be right here. 2, comma half would be right here. 3, comma third, probably right there. Negative 1, negative 1, right here. Negative 2, negative half, right there. Negative 3, negative third, right there. Half, comma 2, probably there. Negative half, negative 2, here. So it seems as though it's like a curve. And the curve will kind of go like this. Now here's a question you want to ask yourself. Can x equal 0? Can y equal 0? And the answer to both are both an emphatic no. No way, Jose. You cannot have x equals 0. Reason why is because y would be undefined. If x equals 0. Also, 1 divided by x can't equal 0, because in order for a quotient to equal 0, 0 divided by a number will always equal 0. But notice that what we're dividing on top is a 1. You have 1 divided by x, so that's no way we can ever get to be 0. So in this case, y can never equal 0, because 1 over x can't equal 0. And x can't equal 0 because you can't plug in 0 into the bottom of a fraction. So this means that we're going to have two asymptotes. You have a horizontal asymptote at y equals 0, and we have a vertical asymptote at x equals 0. You must include the asymptote in your graphs. I know sometimes I don't mention that in quizzes, but I will be looking for that. So don't say, oh, I didn't know how to draw it. You got to draw it. So here's y equals 0, and there's x equals 0. What this means is our domain and range will be all real except 0. Range is all real except 0. So that's typically how rational functions will work. So let me do one more example, and then I'll give you guys a couple problems to do over the weekend. Then we'll discuss more detail on Monday when I see you guys. Let's say I ask you to graph the following. Graph y equals negative 4 x plus 2 minus 1. So this one's a little crazy. Now, some things to keep in mind. The general formula for rational functions will be the following. So in this case, h equals negative 2 and k equals negative 1. H will always impact your vertical asymptote, because we've got to go 2 left. K will impact the horizontal asymptote. That's because we have to go 1 down. So that means that the vertical asymptote is going to be x equals negative 2, and the horizontal asymptote will be y equals negative 1. Do that as your first step, because you kind of need to know the foundation for this graph. Okay. One, two, three, four. 1, 2, 3, 4. 4. 1, 2, 3, 4. So x equals negative 2. And y equals negative 1. And again, you can't plug in negative 2. That's why it's a vertical asymptote. So we have to have as a boundary. And also, y cannot equal negative 1, because this right here, this fraction, is never going to be 0. It can get close to 0 but never be 0, so therefore we can never get negative 1 for y. That's the reason why we have these asymptotes. I'll talk about asymptotes more theoretically on Monday. Might be a little too much for a video right now. But h impacts the vertical asymptote, k impacts the horizontal asymptote. And then what we can do is make a quick table. So the first step was the asymptote. Second step, quick table. And I'm going to choose the following values: negative 1 and 0, and negative 3 and negative 4. The reason I choose these values is because they're very close to the asymptotes, so I can kind of see how the graph is turning when we get close to the asymptotes. And I notice I chose 2 to the left and 2 to the right of the vertical asymptote. So 2 x values to the right of your vertical asymptote, and these will be 2 x values to the left of the vertical asymptote. If I plug these in, so I plug in negative 1, I should get negative 5. And plug in 0 for x, I should get negative 3. So it'll look like this: negative 1, negative 5, and 0, negative 3. So the graph looks something kind of like this. Plug in negative 3, I should get 3. And plug in negative 4, and I should get 1. Yeah. So negative 3, 3. Negative 4, 1. So that's how your graph will look. Domain and range, all real, however, except. Domain is all real except negative 2, because you can't plug in negative 2 for x. Range is all real except negative 1, because we can't get negative 1 coming out for y. So, just to recap, consider a general formula, figure out what h and k is. H will be part of your vertical asymptote, k will be part of your horizontal asymptote, because that's how the graph is shifting. Once you know the asymptotes are, graph them, then make a quick table, plug in some points, 2 to the left of the vertical asymptote, 2 to the right of the vertical asymptote, figure out what the y values are, and then state domain range. So hopefully it seems like a pretty standard process. You'll have a chance to practice on Monday. And that's it. We're all done for the video. So enjoy the beautiful weather today, and I'll see you guys on Monday. Okay, goodbye.